Hey mathematicians, here is a how-to for the study guide for Friday's little assessment. Our first problem says the simple interest owed on a loan of $4,800 after 6 years is $1,440. What percent represents the yearly interest rate on the loan? So this takes the formula that we have been using for interest and kind of applies it to our equation solving problems. We know that interest equals principal times rate times time. We also know that that pen is huge. Can I make it smaller? Nope. Cool. Love that. Okay, so we need to identify what each of these things is. The loan was $4,800. That's my principal. 6 years is my time. And 1,440 is my interest. The simple interest owed is. So I'm going to take those numbers and plug them into my formula. Interest, 1,440 equals principal, 4,800 times rate. We don't know the rate, we're looking for it, times time. Time is 6. Okay? So now I've got this equation and I'm looking for R. I know that when I multiply, the order doesn't matter. So I can rearrange that. I'm going to start over here to give myself room. Keep interest, and I'm going to put the principal and the time together so I can start combining my like terms. So now I can combine like terms. I can do 4,800 times 6, and that gets me 28,800 times R, and this is just a one-step equation. I need to get R by itself. Undo your multiplication. And I'm going to do 1,440 divided by 28,800. And that gets me 0.05 is R, but they said what percent? And this is written as a decimal. So let's think about how we might convert that to a percent. We know percents are always out of 100. This is out of 1. Decimals are compared to 1. So how could I get this to out of 100? Multiply by 100, multiply by 100. So we can find that the yearly interest rate on the loan is 0.05 times 100, or 5%. All right, here's problem number 2. It tells us that Ella deposits $975 in an account that pays 3.5% simple yearly interest. She doesn't add or withdraw money. What amount is in Ella's account after 7 years? Show your work. So remember, our formula is interest equals principal times rate times time. So I think we're going to have to find the interest first and then add it back to the amount she started with. So she deposits, there's our principal, 975 times our rate, and remember that we can't multiply, add, or subtract percents to regular numbers to dollar amounts, so we're going to change this to a fraction or a decimal. We know that percents are always out of 100, so if you just want to say 3.5 over 100, you can. If you want to convert it to a decimal, that's fine too. You would punch 3.5 over 100 in your calculator, and that's 0.035. What amount is in her account after 7 years? So our time is 7 years. So we're just going to plug this into our calculator, 975, 0.035 times 7. The interest she gets is $238. And my calculator says 0.875, but I know with money I have to round to the hundredths. I want 2 digits after the decimal, so that becomes 0.88. So there's her interest. But she doesn't add or withdraw any money. So that original 975 is still in her account as well. So we're going to add that to the interest. And that gets $1,213.88. All right, we have field trip tickets that are $75 per student. In September, the price is reduced to $60 per student. In-state students receive an additional $10 discount. What is the percent discount off of a $75 ticket for an in-state student to go on the field trip in September, round to the hundredths place? Boy, that's a lot to keep track of. So I know that our starting amount our 100% is $75. We're looking for an in-state student, so we do get the $10 discount, and it's in September, so it's going to drop it to $60. And we're going to look for the percent discount. So we have to find the amount of discount first, right? So if it drops from 75 to 60, that's a $15 discount. And then you get an additional $10 discount for being in-state. So overall, these tickets are discounted by $25. So if we're looking for percent discount, we know percents are over 100, and we're going to look at discount compared to the original amount. We know it was discounted $25. The original amount was $75, so we're just going to plug that in, and we get 33.3. Continuing. We need to round to the hundredths place. So that means our second value right here, we know 3 will continue on forever. So this is where we need to have a value. That 3 next door, this guy, says stay the same. So we just cut it off, and we say 33.33% discount. Now, since they said discount in the word, we don't need to have the negative, right? If they just said what was the percent change, then we would say negative 33.33%. All right, Thelma wants to spend less than $25 on her online book order. Which of the following are in Thelma's budget? So we've got all of our options here. We're just going to work our way through and see which ones get us less than $25. So A says 25% off of 40. So we could say X over 25. No, we don't. That's a lie. We say 25 over 100. I lost my marbles there for a second, guys. Sorry. Because it's 25%. Duh, silly mistake. And X over 40, because that's our initial amount. We solve it. You can do L method. You could recognize that we're just dividing by 4 to get from the whole amount to the part. Whatever. X is equal to 10. So that's our discount. If we do the original amount, $40, minus our discount, 10, that gets us 30. That is not less than 25, so A is not going to work. Could you also have done 75% of 40? Because 100 minus 25 is 75. Yes, and then you don't have to subtract at the end. You'll still find out the book costs $30, and we don't want that. Okay, our next one is 10% off, $27.50. So we'll set up our ratio here, our proportion. 10 over 100, X over 27.50. You can do the L method. You could recognize that to go from whole to part, you're dividing by 10. Either way, we're going to get X is equal to $2.75. So we will then subtract 27.50 minus $2.75. That gets us $24.75. Yes, B works. We like B. Okay. Could you also have said, hey, 100% minus 10% is 90%, and found 90% of our original amount? Absolutely, and then you don't have to subtract at the end. Our next option says $20 plus a 15% sales tax. So 20 is our starting amount, and 15 is a percent, so it goes over 100. We can do our L method if we want, and that gets us $3. And remember, sales tax is going to add on to the cost. So is $20 plus $3 less than 25? Yes, C is good. Option D says 50% off of $60, then an additional $2 off. So first we find 50% of 60. Some of you can probably do that in your head. That's okay. I know that 100 divided by 2 gets me to 50, so 60 divided by 2 is 30. So with that 50% discount, my book is $30, but I get an additional $2 off. That means that that book costs $28. Does that fit in her budget? No, that does not fit in her budget. Next, we have $22 plus a 12% sales tax. So let's find our sales tax. 12% of 22. We can do our L method if we want. That gets us $2.64. And then that adds on to our price, right? Sales tax makes it cost more. So we add $22 to our sales tax. That gives us $24.64. Is that under her $25 budget? Yes, E is fine. And then we'll go over here to do F on the side. 30% off of $30 and then 10% shipping. So let's do our 30% of 30. So this is my percent over 100. $30 is the original amount. And we're going to calculate. And that tells me the discount is $9. So I'm going to, since it is a discount, I have to subtract it away. 30 minus 9 equals $21. Then we have 10% shipping. When you pay shipping, that adds on to your cost. So I'm going to find 10% of 21. 10%, because the shipping will be based off of the new price. 21. And that gets me, you can do your L method, you can do however you want to solve that. We could divide by 10, divide by 10. That tells me shipping is $2.10. So I'm going to take my $21, I'm going to add $2.10. That's $23.10. Yes, that is within our budget. So our answers are no, yes, yes, no, yes, yes. Okay, our last question says the PTSA buys shirts for $7. They mark up the price by 80% to sell in the school store. We know markup makes it more expensive. For the last week of school, they sell the shirts for 25% off. We know that that's going to decrease the price. How much profit does PTSA make on each shirt sold in the last week of the school? Profit would be the amount that they sell it for minus the amount that they bought it for. So we have to find out the amount that they sell it for. So our first step is going to be to figure out what the price is after markup. So we know that markup is 80%. We could find 80% of 7 and then add it back to 7. I'm going to take the shortcut. I know that they're going to sell it for all of the $7, the 100% original amount, and 80% more. So I'm going to find 180% of 7. So I can save that step. That tells me that they are selling the shirts for $12.60. Okay, that's during the regular school year, right? For the last week of school, they sell the shirts for 25% off. So I could either find 25% of the shirt cost and subtract it away, or I could ask myself, if we start at 25% off and if we start at 100% and lose 25%, what's left? Well, 100 minus 25% is 75%. So I'm going to take our shortcut and find 75% of $12.60. Remember, stores are going to give you a percent off of the price that they sell it for, not their wholesale price. So they are going to sell the shirts for $9.45. So now my question is, how much profit does PTSA make on each shirt sold in the last week of the school year? So if they are selling it for $9.45, you show up, you give them $9.45, they have already spent $7 just to buy that shirt. So what does PTSA get to keep? $2.45.